So as the kind of title says, this is really a talk about Docker from a kind of different standpoint to what sort of traditional kind of view of Docker has been. So Docker is really gained favor and is pretty much becoming very quickly a de facto way to run a lot of applications in production. And people understand that. People understand how to containerize, how to take an application that they want to run and break it up into containers. And how to build and deploy that, and there's an ecosystem spawning of container schedulers. So around. So there's Amazon have ECS, there's Kubernetes, there's Apache Mesos. So the actual runtime environment is pretty well understood. I'm not really going to dwell too much on this as part of this talk. But really focus on, I guess, the other side of it, which is I'm a developer, and I've been developing software for a long time, and I've been using build tools for a long time, and they all suck, like blatantly, right? They all they pollute your laptop, they do all sorts of things. So let me just quickly go through. So Docker, everyone knows. If you haven't heard, who hasn't heard of Docker? Two people, cool. Okay, so I'll do my two-second spiel on Docker. So Docker is a tool for modularizing and isolating your application into essentially a single process, encapsulating all of its environment, including all of its external dependencies, and freezing that in time. It's essentially a tool that's existed before Docker, it's built on top of a technology called Linux containers, which has been around and was contributed to the Linux kernel by Google, I don't know, however many years ago, quite a long time. But it was really hard to use. You had to be a Linux kernel engineer to basically use it. And a lot of actual companies did do it, including Google, but other companies started doing it as well, using LXC, pure LXC. And then actually a company that did do that was actually the company that founded Docker, .cloud, which basically created Docker from the pain and suffering they had from building their own platform as a service type offering. And so that's what they've pivoted and turned that and created Docker as an open source project. And so it's becoming really, really popular to the point where even Microsoft are getting into the game now. So I actually had, about a week ago, I had a Docker container running Windows Server 2016 in a Docker container. The image was 2 gig, but I could only run it on exactly the same OS that I was running it on, the same version, down to the patch level, but it worked. So the problem. So so who here's gone onto GitHub, gone to a Java project, and checked it out? Oh, it's a Maven project. Cool. I know how to build that. That's one of the reasons why I really like Maven is I look at a Maven project, I go, I know how to build that. Maven clean install, right? I know how to do that. What does that mean? Well, that means I have to have Maven installed. I have to have Java installed. Well, we're Java developers, we probably should have Java installed, but even that, I don't have Java installed on my laptop, and I develop Java. So, you go and you run it, and well, there's a probability of it working. There's, if it's a good open source project that you found, chances are the build should work. Clean install should actually give you what you want. And then often it doesn't. Or if it does, you've had to go away and make a coffee and then maybe go to lunch and then come back and the build might be done. So especially if it's the first time you're doing it on a clean laptop. So that's that really it is about, and the other thing that's really important there is I get the build working on my laptop. Awesome. What about the 10 other guys that are sitting next to me? They've gone and done it differently. Or you've got this README, right, in your repo that says how to set up your laptop, which has got 700 instructions. Install this, do this, make sure you copy this here, put that file over there, edit this config file, and then run Maven clean install, and then cross your fingers and hope that it works. So every developer's environment tends to be different. So every developer likes to build different. In the kind of Java world, we've kind of understood the concept, and Docker kind of really takes this to the next level as well. that we create, we're building a web app, right? So the artifact that we produce out of that might be a WAR file. And you know, if we're good developers, that WAR file that we build is the same WAR file that we deploy in every environment. The only thing that's different about that WAR file is externalized configuration that we deploy as part of each environment, right? So that WAR file that we put in our development environment, our test environment, our production environment is an MD5 checksum exact copy. Because we can then put our hand on our heart and say, yep, that's what we tested. Right? The only thing that's different is the external environment that we injected into it. And so Docker actually provides you an even better way to do that. So instead of you packaging your application as a WAR file, you can package the Tomcat instance that WAR file runs in that container as well. And make the thing that you ran in dev, test, and prod is exactly the same image and all of the dependent libraries that go along with it. And then, again, good practice is that you externalize any of the environment configuration with your Docker file, with the Docker build image. You can inject your environment into that container. So that is exactly the same container that I ran in dev test. So that's cool, and that's pretty well understood. But how do I build that container? How do I build my app and then build the container that contains my app? So right now, that's a really fluid space. No one's really looking at how to do this. Everyone just goes, oh, well, you get there somehow. And so, and as part of what I guess part of my role recently, I've been working in, I guess, sort of the sort of infrastructure side of things and building an automation of cloud infrastructure for about the last 3 or 4 years, and working with development teams on processes for automating that. So yeah, okay, we can automate and we can build a production environment, but also we can go back and build exactly the same environments. And then we want a process to deploy between those environments. We want a repeatable process. We want a process to say, if I built something and tested it in development, that exactly the same process that I used to build that and deploy that is the same in every environment. And one of the things that I've realized, and this is really the evolution of Docker, is not only can we now package our apps up in so the way that I run my app, I don't care whether it's Java or not now, is Docker run. What's inside that container will take care of what needs to run. And so from an infrastructure point of view, that makes life really simple. I don't care if my app's Java, PHP, Python, Django, whatever, I don't care. I just do Docker run. That's how I run my app. Okay, well, what about building my app? Well, okay, well, if it's PHP, I just check it out and maybe I run Composer. Okay, well, that's a build step now. Previously, you know, you check out a PHP app, just check it out and from Git and nothing. You know, all your dependencies are all there. It's, you know, with Composer, it's a dependency management tool. So you run Composer install. That's building your app. You have to do that. A lot of people do that on production servers. Scary as hell, but they do. So the idea now of being able to package that up, the same with the Java app, build my WAR file, put that in a container, deploy that. But again, it comes down to the build process. I want the same Docker run to build my app. And that's what I set about doing. About 8 months ago, I started working on standardization for builds, so that I don't care if I'm building a Java app, PHP app, Node.js, whatever. I just run Docker run to build it. And then I have containers take care of the rest. I don't have to have any of those tools installed on my machine. I can start from zero. You know, this is the classic thing, right? Git clone, awesome project, Maven clean install. This is what happens when I run that command on my laptop now. Maven not installed. Oh, I could just, what about, oh, well, I don't know, I use Homebrew, right? I'm a Mac guy, I can just brew install anything. So I don't care what tools I have. So I can go brew install Maven. I don't even know if that's actually the right package name for Homebrew for Maven. Could be called that. So that's really, like, that's the, you know, the dilemma, right? Especially because of the way that we work at our organization. We work with lots of different companies and lots of different development teams. They all have different tool chains. for builds. They all do things differently. Even the Java shops that we deal with, right, all have different ways of doing it. Some are using Ant still. We have to this, like 2 days ago I did the same thing I did for Maven, I did for Ant. And I've done it for other languages as well. What that means is that from a developer workflow point of view, the build process is consistent. It's repeatable, and I know that another developer can check out that repo and run the same command, and it's going to work exactly the same. So that's pretty powerful. That's cool. That's from a developer's point of view, but that's also the same from your CI tools perspective, right? So what most of you would build stuff, and I hope that none of you are building stuff on your laptop that's going into production. Put your hand up if you are. Come on, let's no? Anyone? No one's going to admit to it? You should be using, there should be some build process, should have some tool. Jenkins, Bamboo, I don't care, whatever, TeamCity, I don't care. I have my preference, I use, Jenkins. You should have some tool doing that process for you, generating those artifacts in a repeatable way. But then you have the same problem, right? You go to Jenkins, and Jenkins has its own way of doing the build, right? It understands Maven projects, cool. You've got to set up the repositories, you've got to understand all of that stuff. Yeah, that's kind of a bit sucky, because then Jenkins is different to all the developers build. So that's pretty weird, right? I as a developer, when I work locally, I do this, but when I go to Jenkins to try and do stuff, it's doing it completely different. It shouldn't matter who's doing the build. If it's a developer or tool, it should be the same. And that's again, that was again the problem that I was kind of, looking at, because we do a lot of this. We do a lot of working with customers, setting up CI processes, CI pipelines, to the point where we've actually created a tool. And if anyone's interested, when I show you the demo, I can show you, I can show you the process, and if you're interested in that particular tool, it's an open source project on our GitHub, on the Base 2 Services GitHub, which I can point you at. So how does Docker help with the build? So, run Maven in a container. Huh? What? So what I mean is, instead of Maven being installed on your laptop, Maven runs inside a Docker container. That's running on your laptop. If you're running Linux, cool. You can just do it natively. If you're running a Mac, you can use Docker Machine or Boot to Docker or any of the other Docker tools to do this. I use Docker Machine. It seems to be it's okay. There are many ways to solve this problem. But Docker Machine is what I'll be using in the demo. So what does that mean? So I'm now running Maven inside a container. So Maven running inside a container means that the version of Maven that my build is using is the same. Everyone uses the same version. If you decide you want to go to a new version of Maven, you change the container, rebuild the Maven container, and you have a new version. You can tag it. You can say, actually, my build needs to be able to run against Maven. I don't know if you're stupid. Maybe maybe you still got a Maven 2 build, and maybe you've got a Maven 3 build. So you can build containers for specific versions of the tools that you need to be testing or building against, right? And everyone can test and do that. And you can set up a matrix build in Jenkins to go and build your app against those different versions of Maven. And it's really easy to do. And so you can manage your build environment that way. So okay, I'm running Maven in a container, but how do I? So it's running in a container, but I've got the files checked out on my laptop. Just did git clone on my laptop, and I've got the files there now. Now how does that work? So what you can do, Docker has really quite a powerful construct for accessing host file systems. So you use volumes. You can basically run Maven. And I'll go through this in the demo. It's a bit more clearer when you see it in a demo. you can run that inside, and it can access the host file system. Yep, sure.
What about Maven cache?
Sorry?
What about Maven?
I will solve that problem too. I will solve that problem too. And that's actually, and when I get to the demo, it'll be very evident why I've solved that. So Maven cache is exactly the problem that this solves. And the technique for solving those problems, there's a technique in Docker called data containers. And data containers are your friend. They are massively powerful, what you can do with them. And I've started using them extensively. It means that my data and my container that has my application are completely separate from each other. And I can independently upgrade and manage them independently. Let me just jump in. So who wants to see it in action? So let's jump in and actually show you. I will start with, I've just cloned this repo, and I'll show you. There's some code here. It's an open source project I look after. It's pretty old school, but it's a Maven build. I thought, oh, well, I'll start with something I know. This is an open source project I look after, have for a few years. So as we know, there's our Maven POM. It's a Maven project. I know what to do. MVM clean, just to prove that I wasn't lying. Maven. Shit. So yeah, brew, install, Maven, run the build. I don't really want to do that. So how do I solve this problem? Let me just get rid of a few files. So here's my project I talked about before. It's a bit hard to see. I will zoom in on the files when they make sense to do so. But what I've done is I've created a container. I will show you this one, and I will zoom it up. Right. This is Maven in a container. This is the Docker file to create this container. I'm leveraging from Josh Graham's awesome work on building a really, really, really lightweight Docker container to run Java. It actually runs Zool. Who knows Zool? Everyone knows Zool? Yes? It's the Azul JDK, OpenJDK build. Freaking cool. Yep, it's awesome. That's free and open source. Very cool. It's really lightweight. So just when I build this container, I will show you. So basically, this is not that relevant. This is there's a GitHub repo. My GitHub repo has these containers. Not that important, but basically what we're doing is actually installing Maven, as you would probably on your laptop. I don't know, curl it, maybe stick it in a directory, that kind of stuff. I'm also putting Git on here because I could also run Git if I felt like it. This is just some stuff to get Maven to run properly, healthily. Doing my, best practice. I'm not actually running Maven as a root user. I'm running it in my container as a user. So you can learn how to, Docker file syntax is kind of unique. What's really important is a couple of things here. So I create a user up here, and I tell the Docker file to run everything after this point as this user. I create this thing called an entry point. If you notice, that's my Maven command, and that's kind of a helper to say, if I just run this container, just assume I'm running Maven. It means less typing when I run, and you can create aliases so it actually looks like you're running Maven on your local machine, even though you're running it via Docker. I can alias MVM to the Docker run command that I need to run. So an entry point. So if I run this, it just prints out the version of Maven, and I'll show you this. I can show you building this and running this. So let's go and build this particular container. I have in this repo, I have a little build script. as well, which just builds the containers. Docker build -t Gentrata Maven, and I'm telling it to build this one. This other one's there for the next part of the demo, but let me just do this first bit, and then we'll get to the other problem later. So what I need to do is just run this build script, and because I did this before, this will run really quick. Can you see that? I can make it bigger. That ran really quick, but basically what it did was, because I'd already done this, and this is an awesome thing about Docker, it caches layers. So as I run each command in my file, it won't necessarily, if I haven't changed it, it doesn't need to rerun it because it's cached. Because Docker uses essentially a version file system, right? It's a copy on write file system. So it knows that if this has already been run, it's already downloaded Maven and run this block. And I'll explain that. I could have. You see this a lot in Docker, and there's a reason why you have one run command. I could have made these individual run commands. I don't want to do that because of two things. One, if I did that and see I've downloaded Maven, and then just before I'm finished, I remove it. And I do this all in the same command because that means that from this point forward, this file never existed in the container. If I did this in a separate run command, that layer would exist forever, which means that the size of the container would grow quite exponentially. To give you an idea, the size of the container for this JDK image is about 80 meg. Actually, the JDK one's slightly larger. It's like 120 or something like that for the JDK. But the JRE, if you just need the JRE, it's like 80 meg for a full container running Java 8. You try like starting with even Debian Jessie or something like that, was one of the lighter late distributions, and install OpenJDK, you end up like with a 300 or 400 meg image. And image size is important when you start dealing with Docker a lot. You'll learn this. I learned it the hard way, running out of disk space all the time. So the reason why we do all of these things in one command is because anything that we want to remove and we don't want to have historically in our image, we want to do it in one command. Because each one of these commands translates to a layer in Docker, and then a layer is essentially immutable. There are tools to go and squash them and stuff like that, but basically the good best practice is to try and do this. When you are developing them, I strongly recommend you have these as individual run commands, and when you have it working, you turn them into this syntax. Because if I didn't, and I kept making a mistake here, or adding more and more commands here, it would do this again, which means that it would go and download Maven every time I ran this. The nice thing about this, if you did them as individual, it's really fast, and then at the end of it, you kind of collapse it. So it's kind of just a development trick for this. So I've now built that container, and I'll show you Docker images. And I will show you the images that we just created. This is 2 hours ago, but trust me, I created it. It's because I haven't deleted it. And I don't want to waste your time sitting here waiting for it to download Maven. So, cool. Now so let me just run that container for you. Another thing you'll learn, this particular switch, let me try and switch that to the top. --rm. So when you run a container, if you don't have this flag, let me just do a docker ps-a. This shows me all of the containers that are running. So there's nothing running, and there's nothing that has run. I'll run it without the flag and show you. Docker run. So I've got let me just run that Maven command. So let me run that Maven container, gentrata /Maven. There we go. Cool. Java 8 and Maven 3.3.3.3 installed. Right, cool. So that's Maven running inside a container. Okay, now how do I use it? So now if I do the docker ps again, you'll see that there's a container there. What it's done is it's created the volumes on my disk. So however big that container is, let's find out how big that is. Docker images. Let's find out how big that container is. That container is 181 megabytes.
Why did it say exited 14 seconds ago?
That's because when I ran it, that's how long ago it ran. It took me 14 seconds to show you that PS command. It'll now say exited 50 seconds ago. Because it exited. I ran it, but it ran. Ran Maven and exited. Normally what would happen is you'd run a Docker container and you'd be running, I don't know, Tomcat, and you'd leave Tomcat running and the container would stay up. But I just got it to run a command. That's why it's exited. It's actually validly exited. If you saw it exited with a status 0, so it didn't even error, so if Maven failed, then that would change to an exit, to a non-zero exit status. And that's useful for picking up other build failures and stuff like that. Docker will exit with the appropriate exit status. So I can see that I've ran, and if you do that a lot, so that means there's 181 meg that just got created on my disk. If I run it again, get another one, do it again, there's 2 now. You can imagine that very quickly gets very old, especially if your images aren't as small as that. If you're running, like some images are over a gig. You run that a bunch of times, you fill up a disk pretty quick. So the --rm, so if I do that again with my --rm flag, and then you won't see that container there anywhere. Another command you will learn a lot is docker rm-v $docker ps-a-q, and I've alias that to drm all. Oops. drm all. Yeah, there's none. But basically, that's remove all exited containers. If I had containers that are running, say I was running my app as well, they wouldn't kill those. It's just nuked all those images. Do a docker ps-a. Cool, gone. That's all good. There's no images there. And the -v is really important on the RM, because the -v means delete the volumes. Otherwise, it would just delete the image and leave the volumes. And then that leads me to another thing, which is there's a way to detect that, and there's tools for cleaning up those orphaned. Operationally running Docker in production, you'll learn a lot of things.
Where are those volumes actually on your hard disk?
They're in my Docker machine. That's what I forgot to show you. How I actually even have this. So I have installed. The best thing to do, just get started with Docker, is to install the Docker tools. Docker now has this thing called the Docker Toolbox, which installs everything, including VirtualBox, which is what this is running on my Mac. So Docker machine ls. Whoops, let me kill something. God damn it. Right. So DM. So I alias Docker machine to DM, right? So I can do DM status MelbJVM. Status running. So I've created this earlier. There's Docker machine create VirtualBox, blah, blah, blah. Pretty easy. That's basically running. So I can, if I wanted to, I can Docker machine SSH MelbJVM. If I actually wanted to SSH to it. It uses boot to Docker, so now this is a Linux VM running, so I can just be in here and do it from here if I really care, but I'm not. One thing to note, let me just do this, ls-al. So on my Mac, it's mounted this. No, you can't see that. Why did it not scroll? There we go. It's mounted this users directory. So this is how the Docker machine or the VM knows about me and my user. And I'll show you when I run this command to actually do a build. So let me do a build now. With this, now I have, let me exit out of here. Control D. No, Control Shift D. Control D. So, Docker machine. Okay, so I'm now in, let me just check where I'm at. Cool. So I'm here. So I now have a Maven container. I can do a Maven build. So docker run --rm. Now comes the important part. I need to tell Docker about my local workspace. How do I do that? .v /tick pwd. That just tells that. This is the important bit because this is /users /Aaron Walker / blah blah blah, right? Workspaces blah blah blah. So that's really important because that's telling the Docker machine where to mount that volume. So now I need to tell it where to mount it to, and let me go back to the Docker file and I'll show you why I know to mount it on /app. I've created this /app volume, and I've switched to it as the container's working directory. So what I'm doing is I'm going to mount my workspace into this volume. And so when I run a command, Maven's going to run it in the context of running in this directory, which is the root of my workspace, which is where my POM file is, right? So I can go and do that. So, and I want to do app, right? So that's the magic of the volume mapping. Cool. So I now need to run genrada. I should have made the container name shorter. /Maven. Clean. Install.
Can you use that command?
Yep. Let me do that all the way to the top. So that's the command. That's going to run. This part of the command line. This should look familiar. All right. This part, well, not so much. Let me run this. What's our internet connection like? Right, so it's building. Wow. So there's a Maven build. It's running, but crap. This is what happens with Maven builds.
Can I ask a question?
Sure.
While building? The first
I don't-
mentioned that Docker is based on Linux containers.
Sure.
But you have VirtualBox running. So can you please elaborate on that?
Oh, okay, sure. That's a Docker. So Docker, my Mac doesn't have Linux containers because my Mac's a Mac. It runs.
Yeah,
So,
I know, just
right?
this one.
Sure. So the reason why I'm running VirtualBox is so that I can run Linux, and I'm using the boot to Docker Linux distribution underneath. So Docker Machine does that for you, and so there's a way to basically run Docker Machine, create a VirtualBox VM, and configure it so that your local Docker commands will talk to that VirtualBox instance. This could easily be running. Docker can also talk to via a remote port, so that Docker service or that Docker instance could be running on a machine in AWS in the cloud.
Does it essentially mean that everything that's running at the moment is running on virtual?
Correct. Correct.
Could you use something like VMware or?
You can. Yeah, there's nothing stopping you doing that. It's just a matter of opening the right ports for Docker for you to talk to. I'll show you the config in a second. When, like, I'm not gonna let that run because I'm not gonna bore you. That's actually, that's a clean Maven run. I've just ran Maven with nothing installed, so no Maven cache. My Maven cache is empty. Right, so that's a problem because that's the problem, right? That's the classic developer problem. I haven't solved it yet. I've just solved one problem. I don't have to have Maven installed on my laptop. That's not really very good though, right? Sorry. We'll get to that. The M2 folder right now is in the container that's running Maven. And notice I did a --rm. That container is about to get deleted when I'm finished. So that's gone. Right? So that's sucky, right? That's, it's like starting with a new laptop every time. I haven't got a Maven cache. So I went, and I got this part of this problem solved pretty quickly. And if you run this build in the cloud with decent bandwidth, and it's actually not that bad. It's it's a bit sucky, but so let me just show you the setup for Docker Machine though. Let me kill that because no one wants to wait here. I think that took, I don't know, when I was testing it, it was taking like 8 minutes or something. I don't have 8 minutes. So let me look at the Docker setup. Now I alias the crap out of this, so I can't even remember the original command. But let me, let me type alias. and see what I actually alias that to. A function, even worse, because it takes parameters. So if I do Docker machine, I alias Docker machine DM because I can't be bothered typing Docker-machine all the time. Let me think about it for a second. So what do I need to do? I need to do init. Right, Docker DM init. MelbJVM. Huh? What's the alias? So, because I alias D to D init. MelbJVM. Yeah, that works. Okay, so now I alias. I can't remember the syntax because I aliased it like a year ago and forgot it. You can see my alias. I like aliases. Dinit, Docker machine init. That's a function. Cool. Which is in my bash functions. So cat. Sorry about this, but I need to show you because it's a bit, it's important. Dot files. SSH. No, not SSH. Bash. No. Where is it in shell? That's where it is. Functions. Docker machine init. Right. Oh, there you go. env. There you go. Docker, so machine env MelbJVM. So this is the config that you need to set. So Docker machine allows you to do it, and it gives you the command run eval Docker machine blah blah blah, which is what I aliased, right? So, but basically you've got to export these variables, these environment variables. So the important one is the host. That's where Docker machine is running. That's a VirtualBox IP. So that my VirtualBox that I ran, and in fact I could fire up VirtualBox and show you, but there's a VirtualBox VM running. That's that IP address, and the Docker service is listening on that port. So I'm basically, when I run a Docker command locally, it's issuing a remote command to a remote Docker host that's running in VirtualBox, which is why I can run Docker on my Mac. Because it's not actually the only thing that's running on my Mac is actually a Docker command. It's issuing all those commands to that remote service. That's just a REST API, by the way. There are Java libraries for doing this as well, and I've worked on with a few companies where we've started creating launchers for IntelliJ and for Eclipse, which run Docker to start their app. So you can just go into IntelliJ or Eclipse and go launch, and it stands up the entire stack. Right. That was. Let me go back to what I was doing. So now I need to. You saw how I run that. So the problem was, okay, that's cool, except what about the M2 cache? Okay, so I thought about that too, and worked out a solution for it. Let's go back to my containers. If you saw briefly, I actually created M2 container. Basically, so it's Maven, right? So I'm starting from that container that I just created. And I'm going to refactor these build files into its own project and put that up on GitHub and have the Docker build files pushing to Docker Hub so that you can do this too. I'll work out so things aren't so hard-coded. But basically, what this does is it checks out your project and builds it. Clean install. So we do this here. and then it removes your project. Because I don't really care about the project. What I care about is the cache. So what I'm doing is actually building your M2 cache and storing it as a container, as an image. Once I have this image, I can push this to Docker Hub. I can export it as a tar file and put it up on S3 and have a part of my build process to pull down that tar file and import it as a Docker container. Right? So the workflow is, I actually have that. One of the things I've also done is created this M2 repo directory where you can add your custom ones. Say you've got your, I don't know, some random third-party library that's not in Central and you need to manage it. You can put it here. And this is adding it to the repository. Right? So I'm actually, the ability to basically build your standard, this is my standard M2 repo cache for every single developer is going to use the same one. It kind of defeats you can kind of get away with not having to run like Nexus or Artifactory or something like that. Because you can basically treat that as a image. So what this does is it creates the container, and then it exposes, if you noticed in the previous Docker file, we're actually doing something with this var Maven. This is basically the home directory of the Maven user. So when I run Maven clean install as the Maven user, its M2 repo is this location. So it actually, the home user of the user running Maven is this location. So there's a .m2, right? And I could add a settings.xml, which I kind of had for a while and I removed it because it didn't really add any value. But you could add a custom settings.xml. So if you had some kind of weird build thing that you had to set up as part of your settings.xml, you could add that to this container as well. Or to the base container. Either way, it doesn't matter. So if I go back to, let's rerun that. So let me, so I run my build again. Docker images, and then I run build. It's now building that. It's now building this data container that I talked about before, right? So it's done that. It's actually gone and in step 2, it's gone and step 4, it's gone and cloned that repo, which is why I had Git installed because it needs Git. So it's cloned that repo. Obviously, this would need, if this was a private GitHub repo, you would need to have part of your base container build would be setting up an SSH key to go and clone that. Or what you would do is you would volume mount in your keys. I didn't show that because it was would be really complicated because you've got to be volume mounting about 7 things. But you can volume mount your private key into the container, and then it would just use your auth. When you ran Git, it would use yours creds, your SSH key to do the auth to GitHub. And it works because I have this for private, this working for private repos. The build file is a lot more complicated. And then we run clean install. And we skip the test because I can't be bothered waiting for the test to pass. But I'm building a data container. I'll show you. So I now have an image. It doesn't have anything in it though. There's no cache here. I have to populate it. That's what this step's doing. Populates the cache. So up to this point, we've just checked out our thing. Now we run it. The end of this process, we now have a populated M2 repo cache with everything that we need to successfully build this app.
If you run it with the -rm, won't it blow that away then?
No, because I'm not going to do that. So what I'm going to do, and I'm just going to run this because I have it in my history somewhere. Could search for it, but I can't be bothered. That's the Docker Compose stuff. Docker Compose, there we go. So what I'm going to do is I'm going to run this container. And I'm going to give it a name. This is something different I didn't do before. So this is what I'm doing now is creating an instance of the data. So think of it, images are classes, all right? And we talk Java, right? Containers are instances. I'm now creating an instance of this image, calling it this. And this is important because in the next command, I need to use it. Right, so I'm going to run that. What's it going to do? Right, it's just done the same as before because I haven't changed anything. But now when I do a docker ps-a, I now have a exited container. Okay, that's cool. But what's really important is it's now got a name, so I can reference it via its name. So now I'm going to do.
What happens if it runs again?
Sorry?
What happens if it runs again?
It will fail because it'll say that container of that name already exists. I have to remove it and then run it again. Right? Oh, I can do it. I'll show you. Oops, that one, that one. Already got a container of that name. Called again, but this time I'm going to use this container I just created. So I'm going to do docker run. And actually, where's that command I ran before? Because I can use that as the starting point, that one. So this same command I ran before. There's going to be one difference though. Volumes. It's really hard to type from. I should be used to it. I have a stand-up desk. Right, I'm going to grab this container name. So this command, volumes from, I'll put it at the top in a second once I've got it typed in cleanly. Right, so I've added this additional thing, hyphen volumes hyphen from, and a name of that container I just created. So what does that do? So what that does is that tells this container to mount the volumes that were created by this other container. 10 minutes? Cool. I will speed it up. And run. And you should see a difference. Something I typed wrong. I love it. What have I got? Volumes hyphen from? What's wrong here? Oh, I know why. I have to put the volumes hyphen from before the image. Should just use my history. Right, it needs to go here. Volumes hyphen from. Has to go on the left of the because it's in the Docker file. Actually, it doesn't really matter. Actually, but so there will now be a difference in this. So who can tell me what the difference is?
Go cache.
Go cache. Yep. So it's now building, and you can see it's not downloading anything from Central anymore. Right? So what that basically shows you is that there we go. It's running tests even. Woo, I'm running tests. I'm a good developer. Before I commit, I'm going to run my tests. So that's the difference, right? That now it's now using that cache that's been pre-built or been built and distributed to the development team or pushed to your private Docker registry and pulled down as part of your build. And it's centrally managed.
Would that Surefire plugin download be added to the cache as well?
Sorry?
The Surefire plugin downloaded.
Yep.
Would that be added to the cache?
It would be added to my cache, yes. Because that container now exists, I'm modifying the internal state of that container. I'm adding stuff to its local repo. So yes, any dependencies that you add would be in your one. But what you would then do is have a way of pushing that to a CI server that would then rebuild that image and pull it down. And I'll show you exactly that workflow. So cool, I'm running that build. But let me jump to, because we all have CI, because we're all good developers. So I have this, so that, you saw that command before I was running, so let me just quickly kick this off while I talk. So I can show you the building of the containers. Did that just build? Bet you it's because I haven't changed anything. This is the joy of the beauty of Docker. I just built that right. It's running some weird time zone because I have set the default for the tool I used to build this is LA. Yeah, I'm going to show you. It's so quick that you'll see it flash by. You'll see the build number go up. See the build number get to 5. Because I haven't changed, this is the awesome thing about Docker, I haven't changed anything. So it's actually rebuilt both of those containers. You can go in there and see. That's how fast it is. If I didn't change anything. If I made a change, and I can probably trigger something, I can trigger this other build. So one of the things that we'll look at, so let's look at the configuration for this job. Because what I want to highlight is this is no different to what I just ran. I ran that build script. I could run that locally, right? It's created those containers. And at the end of the run, it shows you the images. Go back to the output. At the end of the run, it's done a Docker images, and it's created them. Because it hasn't changed, they're not being recreated. Right? That was the last time I created them, a couple of hours ago. You can see the size of it now. It's now 477 meg. That's my Maven cache. Cool. So that's cool. I can rerun the build. So now that's just building the containers, but this is the build that runs my app, that builds my app. I'll just build that because that will actually build properly and show it. But let me show you the config. I just want to prove that it's exactly the same command as I ran on my laptop. There's no difference to run the build. This is horrible, right? Who wants to type that in? I could alias it to something else, but no one really wants to type that in. So I've got a solution to that problem as well. So a very popular tool for describing containers is a tool called Composer, Docker Composer, or Compose. Basically what it does is it allows you to describe the relationships between containers and basically a set of containers. Typically a Docker Compose file would have a container with Tomcat and your app, and maybe if you're running a database, it'll have a container for MySQL, that kind of stuff. But this Docker Compose file actually has my app. And if you notice, the image I'm using for my app is this thing called Alpine Linux. It is freaking awesome. It is 5 meg. A full-blown Linux distro container, which is 5 meg. I install Nginx on here, and it's 6 meg. So I have a full-blown Nginx running in a 6 meg container. It's awesome. Alpine Linux for the win. By the way, those Java containers that Josh created are also based on Alpine. So that Alpine is the upstream distro, which is why it's so small. So we've got our app. That just mounts. So this is the trick. So see before I was doing pwd and then mounting that volume? Well, I'm just mounting dot to the app in my Docker Compose file. I've also defined an instance of my M2 cache repo container. And now I'm creating a container called MVN. And I call it MVN for a reason. And I'll show you why. So let me go back to my terminal. Right, so I've aliased, I can do this docker -compose, but I'm not going to bore you with that because I've aliased it to DC. Run. MVN. Clean. Install. Looks a lot friendlier, doesn't it? It's gone and created those two containers, if they didn't exist, and now running my build again. So I didn't have to do -v blah, blah, or even alias it down. I just have a Docker Compose file where I type Docker Compose run MVN clean install. So it now looks very much like MVN clean install if you kind of squint your eyes a bit. But it's exactly the same process for doing that. And so in my Docker Compose file, I could also contain to run my app. So I could go Docker Compose up, and it would actually run the build and start my app, start Tomcat in a container, start MySQL. And if I use data containers, I can start MySQL pre-populated with data, with test data. So that's, I guess, I mean, that's the sort of the power of using Docker, not just for running your app, but for building your app. So what do we, quick summary. Let me just play. So data containers are your friend. Docker can help you create a consistent build. It can get developers going faster because they don't have to go and set stuff up. They just basically install Docker toolkit and go. Your README files for creating your environment look like this, as opposed to 7 pages. And because it's cool. I mean, that's, you know, I think that's pretty cool. So. And the cool thing about that, let me just, is not a Java app? Cool. It's a PHP app that uses Composer for dependency management. Docker Compose run Composer install. I have a Composer in my container called Composer in my thing, which has a container that has Composer in the container and everything works. So my build process is really consistent. Doesn't matter the technology. So if I was Python, I could have a container that had all the Python dependencies already set up, had pip installed. If it was a Ruby app, I could have, and running Rails, I could have exactly the right version of Rails and all of the dependencies in a container to build my Rails app or bundle, whatever. It's consistent. Everyone has the same. That's the important thing. And by an obligatory base 2 services is hiring. So if you're interested in, I don't know, infrastructure development and working with developers on, you know, doing cool stuff, helping them do cool stuff, then come talk to me. Any questions? Yep.
Did you mention that there was some sort of integration with some of the IDEs like Eclipse?
Yeah, so one of the things that we've been working on more recently is creating launchers that can basically use the Java API to call and run Docker, either Docker containers themselves or use Docker Compose to orchestrate the running of containers. So you don't have to leave your IDE, you can just go in there and run that to do that as well. Yep. But yeah, right now it's all custom code. It's not hard. It's like maybe, I don't know, 30 lines of Java code to kind of bootstrap Docker using the Docker Java API. It's pretty easy.
I haven't used Docker much. I'm just reading about it. But what I've heard quite a lot is if Docker runs on an AWS EC2 VM,
yep,
it gets kind of slow in production.
No.
Is that true?
No, not at all. We run a bunch of stuff. It comes down to a number of things. More importantly, is what's in the container and how you built it, right? Because a lot of people go and build a container that they have one container that has all of their services in it. That's not ideal. There's a lot of extra context switching that happens. It comes down to there's networking layer stuff that you need to make sure you've got right. There's other things, but we run quite a significant number of very large traffic sites for customers, and they're using Docker.
The question was more from if Docker runs directly on the raw Linux
Sure.
kernel
Mhm.
as opposed to a VM which is on top of the Linux kernel.
Yeah, no, there's no discernible difference between you running a process in a VM and you running Docker in a process in a VM. There's no discernible difference.
But if you're running Linux, you're running on your host machine because the Linux has the host authority, right?
Sorry?
You don't need a virtual machine if you're running Docker in Linux.
Correct.
Because it's using
Correct, of course. The only reason you need to run Docker machine is if you're not on Linux. If you're on Linux, then you just go Docker, if you're on Ubuntu, apt-get install Docker, or run their horrible curl, their horrible script, which scares the pants off me.
Sorry, 2 more questions, then we have to wrap up.
How many clients do you have running Docker at the moment in production?
I don't know, 4 or 5, something like that. And pretty much all of, a good portion of them now are, if they're in the process of adoption. It comes down to, what we've found is people aren't ready to go down the scheduler path, right? So they're not ready to go and deploy Kubernetes or deploy Mesos or even to any real extent leverage ECS. By the way, that Jenkins instance is running in a Docker container, and the Docker container, you saw I was running Docker builds on there, that's running inside Docker. So I've got Docker in Docker. So that slave that's attached to that master is a Docker container that runs its own version of Docker. I wouldn't, do that in production, but for a build tool, it's kind of cool. So, but that said, so schedulers is a fluid space. It's really fluid. Docker Swarm, there's no one's really cracked that nut, right? Mesos is probably the most mature, and we are looking at it for a few customers, and there are few others that we are considering. ECS is getting better. But so what we do is really use Docker as a transitional tool, and we run Docker containers, and we build infrastructure in the same way that you'd have your classic 3-tier app, right? You'd have a web, app, DB. In the case of cloud, the DB is probably a database as a service solution, so we don't generally worry about that. The app and web, though, we would, in a containerized, pure containerized scheduled view of the world, you would just have a pool of machines, and you would issue a command to run the app container and the web container somewhere in your cluster, maybe with some rules to say that they can't be located on the same physical host, that kind of stuff. People aren't ready for a lot of organizations aren't ready for that. So what we do is, they have a server for their web tier and they have a server for app tier. So their web tier, they might be running on Nginx, and their app tier, they might be running, I don't know, Tomcat, JBoss, whatever, right? We still run, instead of running JBoss or running Tomcat on that server, we run Docker, a single Docker container containing that. And on the web server, we run a single container running Nginx or Apache. And we just orchestrate that using, I don't know, a tool like maybe Chef, Puppet, Ansible, you name your flavor, we've done it. And that's what a lot of organizations are ready for. Because all it really is it doesn't change what they do, it's just a packaging thing. And that's a good way, that's a good path. And we found that's quite a good learning curve, to basically adopt Docker, is start with building containers in development and then start working out how you run them, at least replacing the Java minus jar, or if you're using Spring Boot. It's actually awesome for stuff like that as well, because you can just go Docker run and your Spring Boot app just pops up. So, it's, and start running things like that. And then as things stabilize in the scheduling space, you can start to look at adopting a scheduler. We've started looking at that for a few of our mature customers that have been running Docker for more than a year in production. We're starting to look at, okay, well, they want to go to the next level, right? And so that's where a scheduler will come in.
Yes, is it easy to upgrade or downgrade versions like Maven?
Yep.
Or
Sure. This is where this is something I'm going to work on, because I'm actually going to create a public container, which has a matrix build of all the different versions of Maven. But basically, if I switch back and show you, if I wanted to change the version of Maven that I was working with, I just change this environment variable. Or in fact, what I do is when I run the build command, I pass in an environment variable and set the thing, and I create a tag that says build Maven blah, and it would go and do that. I mean, if you really want, I can show you it. Let's do this. I haven't done it yet, so let's try it. Let's go to the containers directory. let's go and edit that build file. We might as well do this live. So let's build a different version of Maven. Let me comment out those two because otherwise you don't really want to see that. It's boring. So let's just do that. So now what I want to do is I want to do build-t, I want to do -e, and what did I call my environment variable? Maven version, to my build script. Maven version equals, I don't know. I'll show you, there you go. Oops. I have to do it via the... How do you just pass in the... I can't remember how to override the environment.
Wasn't it env?
Yeah. It's --env, I think. Here's my script. Did I even save it? --env equals 3.3.2. Oops. No, I can't remember the exact thing, but I'll show you the outcome of that. The exact syntax would be... Huh? Oh, I've got to get rid of that out of the build file. Change that back. Let's build this one. So you actually now see that's actually downloaded, well, attempted to download, I think my... is that not, there's probably not a version called that. Does anyone have a valid version of Maven? Has to be 3 because there's a hard-coded path in there. Where am I? And is it 3.0 maybe? No. This is the joy of debugging Docker builds, by the way. This is why you split them out into multiple lines. What is it? 3.0? .0? It's whatever in... I have to go and find a build number. No.
For a major version, it might not be that.
Yeah, maybe. Yeah, maybe that's exactly right. That's possibly true.
It's giving you a 404.
Yeah, that's what I'm saying, that there's probably not a version of that version. I just went and grabbed a...
I'm just going to get you
Yeah,
to draw